Hello, thanks for inviting me for a conference. So today we'll talk a little bit about optimizing Magento by preloading data. The talk, first of all, I need to put a disclaimer. The talk is not about caching, so it's actually the part of Magento that is slow behind the cache. So we are going to learn today in this talk how can we optimize Magento uncached versions of the pages and what are the common problems of Magento in that areas. So first of all, let's talk a little bit about the pitfalls of caching in Magento and uh, why actually we shouldn't rely on a cache for performance. First of them is combination of variables that invalidate the cache itself. So let's say you have a lot of things that can affect the final rendered page for the end user. So for instance, you have different customer groups, you have different languages, you have different currencies available in your store. And when you cache something, you need to take into account all of the variables that may affect the final rendered result. And when you employ caching, you also have to clear it up as well. So it means that apart from having those values being differentiating for a cache, also you need to make sure that when you modify relevant data, you clear all the entries related to that data. So it has as a side effect slow updates in the backend, because as more cache variations you have for the same data, the more time it takes for you to clear this data up. Another one is the cache memory usage grows with the catalog size. So if you are not aware, in Magento, every single category page, product page, and CMS page, they have own cache apart from full page cache. It comes from the times of Magento 1. In Magento 1, there was also a lot of issues with that, especially related to layout. And right now, there is layout and there is something more that we will learn a little bit later in the talk. So the layout cache is based on unique handles. So every single page that is rendered in Magento, it has layout handles. And for categories, for products, for CMS pages, for each of them, you have a separate identifier being added to the handles. And basically, it makes impossible for you to cache the whole layout structure just for category pages. It caches it for every single unique category ID. So another one is caching onions. And imagine like you have a lot of layers of caching happening in your system. So one of them, let's say you have configuration cache. Then based on configuration cache or configuration values that are cached, there is rendering of the price happening within Magento. And then imagine that price is being cached. And then you can have that price being part of another block that is cached, let's say some content block like CMS block that contains a widget inside of it that is cached itself as well. And then like you have a multi-layer of the cache. And when you, let's say, change your configuration value, you don't know which other cached values are affected. So it adds a lot of complexity to your system. So as less levels of cache you have, as better your application in the end. So as we found out what are the problems with the cache, let's take a look at the obvious question, do we actually need caching? But in order to answer it, we first need to do a small exercise. And we need to take a look at the standard Magento category page. And how many of you think that there is no cache at all on this page? I think no one. And unfortunately, yeah, it's online thing, so I don't have direct feedback. So I'll just answer for you right away. There is actually a bunch of places where you have, where you have caching. So first of all, we need to take a look here. So this footer block is being cached for every single page separately. This part is being cached as well, the copyright. We also have the top block being cached with all the category structure itself. So that one is a thing as well. And another thing here is that every single product you have rendered in Magento has price calculation being cached itself. So there is a lot of cache levels, and apart from that, the whole page itself, based on your selected options, is being cached by full page cache, either Varnish or Redis, whatever you are using in production. So the question is, what kind of problems the cache tries to solve? So why we have the cache in the first place? And the answer is actually quite obvious. Let's take a look at the top menu. And let's take a look how much time it takes to render the whole top menu if we don't have a cache in place. So this is uncached render of the page with a timeline. And here you can see here marked 1 millisecond of every single category entry. And you can see that every single category invokes a database query to retrieve its URL from URL rewrites. This is kind of a performance issue in Magento that exists in every single store. And here's a thing that just shows us this problem being exaggregated because we have a lot of categories. Another one is product list. So we saw that price being cached. And if we turn off the price cache, we'll see that every single small operation will take at least 8 milliseconds to render a price for a single configurable product, because it tries to walk through every single simple product in order to give you the final price of a product. So what kind of problem is it? Can we give it a name? Yes, we can. And the problem name is a load in a loop, or more well-known outside of Magento world is N+1 problem. So N+1 problem is when you have a query that retrieves some data. Let's say you retrieve 10 products. And then for that query of 10 products, for every single product, you do another query. So it means that for n results in a query, you do n number of queries additionally. So that's why it's called N+1 problem. So why do we have those kind of N+1 problems in Magento core? This is a little bit of my musings on a topic. It's not something that I would say is definite answer, but it's just my speculation why it might happen. First of all, there's a lot of abstraction levels. So if you take a look at the Magento, in the standard Magento install, you have entity repositories using some kind of collection processors. Those collection processors interact with collections itself, and then the data from those repositories being used in other modules that use own repositories that are again abstracted away from the actual database layers that are used in Magento. So the database interactions are kind of hidden away from you as a developer. Also, Magento itself, at least 2.3 till 2.4, 2.3, still has this kind of paradigms that you are using singular service access. So a lot of people are used to use repositories with get by ID or other kind of calls that promote for you to access data for specific entities by singular representation. You never access it get by IDs. You access it by singular. And that's one of the biggest problem why we have N+1 issues in Magento itself. Another one is that Magento itself is designed from the bottom up. So people, when they think about the core architecture, they don't discuss, hey, how I'm gonna render this page from the user perspective. They think, hey, how do I access this stuff through the standard means of Magento repositories, or what my service layer should look like. However, if you would design a system from the entry point of the customer, not from the point of view of how would you work with the database in the end, you would already have a mental shift into designing an application that is oriented on getting everything you need from the database for rendering the whole request, instead of thinking about it from point of view of just thinking how this entity is related to another entity. So this kind of leads to this kind of issues inadvertently. So the question is, can we actually fix those issues just by modifying the core or without modifying the core? So we can, of course, submit pull requests, but in my experience, submitting pull requests go usually nowhere. Like they stay open for 1 year and then they are never getting processed. So I just came up with an idea. Okay, let's create a module that will do it. So what you can do, you can observe load events of collections based on which you see there is a performance issue. Then you can load the data that you think will be used at the later stage for this collection. So you load, let's say, URLs, or you load prices, or you load whatever data is needed at the later stage. Then you can create a plugin around the service that is a singular and that triggers this n+1 problem. And you can replace the data that it tries to retrieve with the data you already preloaded. So you kind of can save some bandwidth and I/O there, and by this speeding up the application. So the good news, there is already a module for that, and it's already published. It's already 1.0 version. Here is the module URL for you. You would be able to access it after the presentation in the slides. So how to use this module? There is only 3 things you need to implement. One of them is you need to implement a data loader interface that is available in the module. You need to implement few methods on it. One is applicable, where you specify a type of the collection, where you receive actually a type of collection which is going to be loaded. And based on this type of the collection, you decide, hey, do I need to load this data or not? There is right now only 3 types of collections available for products. It's a list, where you have just a list, let's say category list, or upsells or cross sells. The list of the products that don't need a real price or a real stock, it can use syntaxes. Another one is cart. It's where product collection is used to populate the price information and stock availability within a shopping cart itself, so to complete a checkout. And the last one is other, where it's neither list, neither cart, it's just something else. And I don't know, maybe in future there will be more, but to split this other section, but for now there is only 3 of them. Another method you would need to implement in this data loader is a load method, and this load method receives a scope filter. The scope filter contains the data scope based on which your products are based, let's say store ID, website ID, customer group ID. In order to retrieve relevant price data or stock information, you would need to load additionally, or any other attribute that's your business logic is based on. Then you have a list of products that actually need to be populated, and list of products is implemented as a product wrapper that just has ID of the product, SKU of the product, and method to check if this product is of a specific type, like is it a configurable, is it a simple, and so on. Then you would need to register a custom loader as a dependency in DI XML. For the loader service, we'll see an example later in the slides. And then you need to use this load service actually to access the data that you've preloaded with this data loader. So this is 3 simple steps how to do it. So, so the loader service has a couple of methods available. So get methods where you can specify a product ID and the type of the data. The type data is something that you define yourself, and has as well has this product ID and type in order to check, hey, do we have data for this specific product with this specific type of data? Let's say my stock statuses or my prices, or whatever your data loader defines. So let's take a look at an example with configurable products. We'll, I think, take a look at a price as far as I remember, or stock data. I don't remember exactly which this example is for. So what is our idea is actually to remove the load in a loop for the price retrieval and to remove the load in a loop for inventory check. Also, we want to achieve below 90 queries on a category page with configurable products. So this is one of the things that this example will help us to achieve. And we want to make sure that we don't expect this code behave validly in all of the cases, because for the sake of simplicity, in this example modules, the stock status of sorry, not the stock status, the is it disabled or enabled for simple products within a configurable product is right now simplified and not checked, but you can add the simplification by modifying a query. But to fit on a slide, it's an example code, and not to make you bored, I omitted that part. So let's take a look at the loader of configurable prices. So as you see, I implement this data loader interface. I define here this public constant data key that I will use later. I call it configurable price. Then I have resource connection being passed in constructor of the loader. So from this one, I'm gonna receive all the required connection settings and select the object and so on. Then I have this load method that takes filter and list of products. And what's important here on this slide is implementation of is applicable method. And you see, I compare the type that I receive to the type list. So my loader will only work on listings of products like category page with product list, or upsells or related products on a product page. Another one is here in more detail, you can see the load method. So first things that I do, I don't want to do database operations if I don't have any configurable products in a data set in that collection. So I walk through products and I check if the type of the product is configurable product. And if it is, then I just aggregate product IDs into an array. And if I don't have any configurable products, I just return empty array, so I don't perform any operation for the set of the data that's going on there. Then I have some chores to do here, and I define a connection, I define the name of the price index table, and I define the name of the relation table. So the relation table is a table that contains the relation of a configurable product to a simple product. It's called product superlink. It actually comes from Magento 1 naming, because before, in Magento 1 era, that specific product type was called super product before the beta was released. But then the name of the module changed to configurable. However, the name of the table stayed the same, super product, because no one wanted to change the name of the table. Now, let's take a look at the select that is executed later here. So we create a select, then we select data from the price index table. We join this relation table, the one that called catalog product super relation. And here we have a join by product ID with the entity ID itself. And then we have our collection, our columns, where an entity ID is taken from the relation table from the parent column. So we aggregate by entity ID of configurable product, because this is a configurable product ID. Then we access the price, and price is the minimal price from all of the simple products related to this configurable. And the final price is also the minimal price of the final prices of the simple product. Then we group by parent ID from the relation table, and then we also add a condition of parent ID in a list of configurable product IDs. We also add a filter by customer group ID and by website ID itself. So in the end, there is a small trick that you probably never heard of in ZendDB. There is a method called fetch assoc, and this fetch assoc method is returning you back the results as an associative array being keyed by the first column within a result set. So you receive the data being grouped by entity ID as a key of this associative array. So this is kind of a neat way to return the data for every single configurable product within a data set without iterating through the data yourself. Then here's an example of the plugin itself around the configurable price resolver plugin. As you see, it receives this load service class as a dependency, and then around resolve price of configurable price resolver object, we just call our load service and we verify, hey, do we have a data for this data key that we defined previously for the specific product? If we have this data, then we just return the final price from the data right away. And if not, we fall back to original resolution of the price for a configurable. So basically, if our data loader was never invoked, this has method will return false and original functionality will be preserved. So in such a way, we prevent ourselves from breaking the price retrieval where we don't expect it to happen. Here is an example how we define this data in DI. So we have this product data preloader load service class into which you have an argument of loaders that is an array type. You can just specify the unique key of your loader itself that implements this data loader interface, and this key should be the same as the value by which you try to access the data from the load service, because it will be stored by this key in a storage. Then you have the plugin for configurable price resolver, and this is basically the plugin we've taken a look just prior. So you can see the link to the example modules and test it out yourself in the most recent Magento version and see how it improves the performance with or without those modules. So here's something that I saw as an improvement after I implemented those fixes that are in that module. First of all, the time to first byte reduced by 34%. However, this is a time to first byte improvement of profiled and instrumented page. So the real page improvement is higher because most of the time is spent in I/O in a live application. But with Blackfire, it instruments every single call of every single function. So time is relative over there. Then you can see that there is at least 62% of reduction spent of the time spent on I/O and 75% less queries. So it's, I think, a good number to achieve by reducing the number of queries by almost 350. However, this is a singular example, and let's take a look how it behaves under the load, because the cache, right, it gets populated as soon as you have people visiting the website and viewing stuff. So here's some load tests with 5 concurrent users over the 45 seconds of the same pages. Here we have the light blue is cached price, where we have a price being cached with the radius as the default Magento functionality. Then we have an uncached price, where we disable the cache for prices. Here we have the optimized result, and we have optimized result plus no special identities call that I just disabled because I wanted to see a difference. Does it make a lot of effect after we fixed the major bottleneck itself? So you can see that the minimal response time from all of them is quite good, except that uncached price is an outlier here because the prices are never cached, so there is no good minimal result for it. However, you can see that the cached price and optimized are on par. However, optimized version is even faster because something that you probably don't know or maybe know that every single cache call is also an IO operation, and as soon as your Redis server is not directly on your VM in the same physical machine, you might have some network latency over there as well. So caching is not always a fast thing to access. So this is on a local machine, so there's difference is very small, but still you see that just avoiding a call is already quite good. Then we have the max value, and the max value, as you see, cached and uncached, there is a difference, and uncached apparently is faster, but it's faster only because there is no IO call to access the data from the cache. So this is the caching overhead basically. The optimized version, as you see, the maximum response time is a little bit slower than minimal, but not too much. We see it's still within 400 millisecond timeline. Then the average response time across cached and optimized is basically on par. The same with 19th percentile and 95th percentile as well. So basically, without cache and with optimized queries, we have absolutely the same performance, and there is no drawback actually going and optimizing the algorithm to access this data behind the scenes. So the key takeaways from my presentation: first of all, avoid using a cache for data within a cached page, because as soon as you have this caching onion, it's much more harder to clear the data properly. Use also single query per set of data. Don't try to execute a separate query per single result item within a data itself. If you develop something, try to disable block HTML cache. And sometimes it even makes sense to disable it in production because you're already using full page cache. And if there is some block that is slow, you can always optimize it with some kind of preloading mechanism yourself. So there is no need for a block HTML cache. It just introduces more IO calls and more deterministic result of rendering of the data when the cache is enabled. Also, don't hesitate to use Profiler. I use Blackfire, but you can also use Tidaways or any other profiling tool. It's very valuable during the development. And as you saw in this example, I was able, by profiling, I was able to create specific optimizations by using data preloading mechanism to get rid of this additional database calls, and in the end achieving better render times without using cache. So a little bit about the future plans. First of all, I want to make it plug and play module. I want to have it just simple composer require with all the examples being implemented as working functionality, very well tested, and so on. I also want to create some common preloaders. I want to also add MSI quantity retrieval for shopping cart and checkout. Right now, it's only happening for catalog in example modules. I also want to fix an issue with FPC identifiers, the one that you saw in a load test with disabled and enabled. I want just to create also another just data loader that does it with correct full page cache identifiers. And then I also want to create a preloader module for categories as well. And as the last step, I want to rewrite setup.di compile in order to improve my development experience and development experience of other developers in the community who daily drive Magento projects out there. So thank you very much. Here are links, and you can ask questions in the chat. Oh, sorry, in QA sections of
or the chat. Okay. Or the chat, I'm here to monitor both. So thank you very much, Ivan, for this presentation. I'm definitely looking forward to the improvements in your future plans. While we give the audience a chance to ask maybe a question, I wanted to ask you, we know that Magento is becoming slower and slower if it's multi-website or multi-store, if it has group pricing. How does your indexer perform in those cases? Because if we see an improvement on configurable products in terms of queries, I think those improvements should be even bigger on large data sets or complex data sets.
Yeah, so the thing that you see here, it's in the data set of 200,000 simple products with 20,000 of configurables. So the test that I've did and optimizations I did with quite a regular fashion merchant, I would say. So it's not indexer, right? It's just the way how you present the data on the front end. So it's not about, like, hey, what is the speed of the indexer? This is actually something that I also want to improve. I want to write an indexer that doesn't take hours to reindex this data set, but takes, let's say, seconds. Because honestly, it's slow and there's a lot of ways to improve that process.
Right. Also, we have a question from Valentin Sandu. So taking into account that block HTML cache is disabled, have you tried to profile a page that is not full page cached, and what were the results?
Valentin, this is actually something that you see on a page. So you saw the two timeline graphs where block HTML cache is disabled, and then the price cache not being used on the page resulted in a lot of N+1 problems and the top menu block as well, where every single category was trying to retrieve the URL. And the numbers that you saw are related to a specific disable of block HTML cache for specific blocks, like the one that I show in the load test. The optimized version is with price cache being eliminated. So only top menu cache being used in the end.
Okay. Michael is asking in the chat, and I'm missing the context here. Probably you have the context better. So I have to write queries for my custom needs.
Basically, it's a good idea in general because honestly, Magento API that haven't been changed in years since Magento 1 is database, right? So basically, it's much more safer for you to write customizations relying on a database structures than writing a customization relying on entity repositories or something else, because Magento always comes with a new shiny idea, and database, there is only difference in database between a commerce version and open source version, because you can have catalog staging enabled or disabled for specific data. But usually, if you are working on a large website or writing a customization for a large website, you usually disable content staging for catalog right away where you start developing a project, because it introduces other performance bottlenecks.
Thank you. So I think that was for the questions. And we're definitely looking forward to the improvements on the reindexer. We would love for it to take seconds and not tens of minutes or hours. Thank you again for your presentation, Ivan.
Yeah, thanks for inviting me. Have a wonderful conference day ahead.